You know, right now, as you're watching this, there's a good chance a chain of satellites is passing silently over your head at about 17,000 miles per hour. But here's the crazy part. They're not spy satellites. They're not for some secret government agency. They are the internet. And how that's even possible, well, that's what we're about to dive into.
It just doesn't seem to make any sense, does it? How on earth can beaming a signal hundreds of kilometers up into the cold vacuum of space and all the way back down again be faster than sending it through a state-of-the-art fiber optic cable that's literally buried right under our feet? That's the big question, and we're going to solve it.
And the answer, it turns out, has nothing to do with better modems or more powerful computers. Nope. It all comes down to a fundamental quirk of physics, a little-known secret about the speed of light itself that gives space one massive, unbeatable advantage over the ground. Okay, so to understand why space is the new champion of speed, we first have to talk about the hidden weakness in the tech we all use and trust every single day, our very own fiber optic internet.
So here it is, fiber's kind of dirty little secret. We always think of it as internet at the speed of light, right? But that's not exactly true. See, when light travels through the solid glass of a fiber optic cable, it's constantly bouncing around, which slows it down, a lot actually, by about a third. But in the pure vacuum of space, there's nothing to get in the way. Light can travel at its true, absolute, universal speed limit.
And that's not the only problem with physical cables. The other big one is, well, you have to actually lay them. It is ridiculously expensive, sometimes just impossible, to run fiber across entire oceans, deserts, or through remote mountain ranges. And because of that, a staggering 2.6 billion people on this planet still don't have a reliable way to get online.
And this is exactly the problem Starlink was designed to solve. But it's so much more than just another satellite service. It's a completely new blueprint for how the internet itself can be built.
You might remember the old satellite internet, the kind that was famous for being painfully slow. That's because it used geostationary satellites. These things orbit at a truly colossal altitude. We're talking almost 36,000 kilometers up. Every single click you made had to travel all the way up there and all the way back. The lag was just unbearable.
Starlink, on the other hand, does something totally different. It uses this huge swarm of satellites in what's called low Earth orbit, or LEO, and they are just 550 kilometers up. That's not a small difference. They are over 65 times closer to us.
And that massive change in altitude makes all the difference in the world. It drops the latency, the signal delay, from that painful 600 milliseconds all the way down to just 20 to 40 milliseconds. That's a 20-fold improvement. It's so fast, it puts Starlink right in the same ballpark as good old-fashioned ground-based broadband.
But this is the real secret weapon. This is the part that lets Starlink actually beat fiber. The satellites don't just talk to the ground, they talk to each other, using lasers. They formed this incredible mesh network in space, shooting data between one another at the true unhindered speed of light. So your data doesn't just go up and down, it gets to take a shortcut on a literal highway in the sky.
So let's see what that looks like in the real world. If you're sending data from, say, New York to London, the undersea fiber optic cable has to take a longer, more winding path. And remember, the light itself is moving slower inside that glass cable. But Starlink's laser network, it can just shoot that data in a much straighter line through the vacuum of space and get it there in nearly half the time.
And look, you don't have to take my word for it. Researchers at University College London confirmed it. For any data route over about 3,000 kilometers, the physics is just undeniable. Space is faster. And this is a massive deal for certain industries, like high-frequency stock trading, where shaving off just a few milliseconds can literally be worth millions of dollars.
So, yeah, the technology is absolutely incredible, but what does it actually feel like to use in the real world? And what are the consequences of filling our night sky with tens of thousands of these new satellites?
Well, the performance is honestly staggering. People have tested Starlink on commercial airliners flying at 40,000 feet and gotten speeds over 350 megabits per second. I mean, think about that. Just a few years ago, getting any kind of usable Wi-Fi on a plane felt like some kind of magic.
But this progress definitely comes with some pretty serious challenges. Scientists are worried about something called Kessler Syndrome, the nightmare scenario where one collision in orbit creates a cloud of debris which causes more collisions and starts a chain reaction that could make space unusable. Astronomers are also concerned about all this light pollution interfering with their research. And, while the tech is revolutionary, the cost is still pretty high for many people in the developing world, the very people who need it most. But believe it or not, this is really just the beginning. The next phase of the Starlink network promises to be even more of a game changer.
So SpaceX's new rocket, Starship, is going to change everything. It'll be able to launch the next generation of bigger, more powerful Starlink satellites in batches of 120 at a time. To put that in perspective, the current rocket can only carry 22. This is going to dramatically accelerate the network's growth and its capabilities.
And the way we connect to it is evolving just as fast. You know, we went from those huge, clunky satellite dishes of old to the sleek, pizza box-sized terminal that Starlink uses now. But the final step, that's the one that changes everything. Connecting directly from a standard smartphone. It's called Direct to Cell. The newest satellites are basically being built as flying cell phone towers. They'll be able to talk directly to the phone that's already in your pocket. No special dish, no extra hardware needed. This is the technology that could literally erase mobile dead zones from the face of the planet. So, when you take a step back, what's the big takeaway here? Starlink isn't just a new internet company. It's a completely new way of thinking about how we build global infrastructure. For more than a century, connecting the world meant one thing: digging trenches and laying physical wires. It was slow, expensive work. Starlink just flips that whole model on its head. The infrastructure is now in orbit. It blankets the entire planet all at once, and the whole network gets a hardware upgrade with every single new launch.
And this fundamentally changes our relationship with the sky above us. So the next time you're outside on a clear night and you happen to see that perfect straight line of bright lights gliding silently across the darkness,
Just remember what you're seeing. You're not looking at stars, you're looking at a global network. You are looking at the internet itself, flying 550 kilometers right above your head.